Assalamu alaikum. Welcome to lecture 1 of chapter 8. The title of the chapter is Phase Diagrams. Let me try to explain quickly to you the order. We started the course with chapter 1, of course, introduction, which tells you about the whole course and the whole field of material science and engineering. Then, rather than going through chapters 2, 3 and so on in order, we jumped to chapter 6, which was about mechanical properties of metals, because I wanted to start with an application of material science chapter where engineers select materials based on their properties for manufacturing, for design and so on. So we started with properties. Then we jumped back to chapter 3. I told you chapter 2 is about atomic structure and so on, so we don't want to cover it. Chapter 3 is crystal structure. So that is now basic material science, not applied materials, basic material science, that if a material has certain tensile properties, then what is the reason? If its hardness is so much, what is the reason? If its density is so much, what is the reason, and so on. So that is crystal structure, is material science. Chapter 4, when we will cover it, will be about defects at the crystal level, at the microscopic level. So that is also basic material science. We go inside the materials, understand the science. But now, rather than going from chapter 3 to chapter 4, I am jumping to chapter 8, phase diagrams. So this is one more of the applications chapter, that if you know the basics of material science, then can you apply it to materials and learn other things. Some of it will be a little bit of science also. Some of it will be a little bit of science also. But a lot of it will be application based part also. So, right, chapter 1, then chapter 6, then chapter 3, now chapter 8. But the way we are covering it, hopefully, will make a lot of sense to you. Right, that the order in which we are doing, we as engineers, we want to apply material science and we learn properties and so on. Then we want to go into the basics of materials at the microscopic level and learn what is inside. Then we again go back to how do we change the properties of materials. How do we change the properties of materials? And therefore, we start with what is known as phase diagrams. So after doing this, we may continue with phase diagrams and so on, or we may go back to chapter 4. We will see, inshallah. Phase is a region in a material that differs in structure and function from other regions. And phases are separated by phase boundaries. You see, we are talking of phase and we are talking of phase boundaries. So if you go to like the crystal structure of a material, right, there is a piece of material, you keep on dividing it into smaller and smaller and smaller pieces. You go into a microscope to see a very, very small part and think of one crystal, one small crystal. So each of the crystals, I mean, even in a small piece of material, there will be millions of crystals, and each crystal has a certain structure and each crystal has a certain function and property. So it has a certain phase, right? Each crystal has a certain phase and it has a certain phase boundary. So if there is a diagram or a figure, right, a diagram or a figure which tells you about the phases inside the material, then it will be called a phase diagram, a phase diagram. So let us go ahead and see what it is. We will start by doing the phase diagrams of pure substances, single substances, where nothing has been mixed with it. And we will start as an example with the simplest of materials, water, right? So rather than saying whatever is there in this slide, let us go to a diagram which explains it much better. This is the phase diagram of water. If you see, on the vertical axis we have pressure, and the unit is millimeters of mercury. So you see 1 atmosphere is here, and 1 atmosphere is 760 millimeters of mercury. The horizontal axis is temperature, and it is of course in degrees Celsius. We know that water freezes at 0 Celsius and water boils at 100 degrees if the pressure is 1 atmosphere. If I ask you what happens if we increase the pressure, if the pressure goes to say 1.5 atmosphere, what will happen to the temperature? Will it increase the boiling temperature or will it decrease? So you see, what is boiling? When you supply heat to water, the water molecules gain more and more energy and they try to move around then, and the higher the temperature, they move at a higher speed. So at a certain temperature of 100 Celsius, their energy is so high that some of these molecules reach the surface and break from the liquid body and go into the atmosphere, and boiling happens. So water changes into what? Vapor stage, right? So it means that for boiling or vaporization, enough temperature is needed so that the kinetic energy of the molecules is so high that it will go into the atmosphere. What is pressure doing? Pressure is trying to force water back into the main body, isn't it? Force, right? So boiling is trying to happen against the pressure. So if the pressure increases, if the pressure in the room is higher, we will need more temperature to break free from the body. You can see the same thing here. You see, at 1 atmospheric pressure, at 100 degrees, the water boils. If the pressure is more, say pressure is here, right? Then boiling will happen here, not here. Boiling will happen here at a higher temperature. So you see, this is the curve. This is the curve where on one side we have liquid and on the other side we have vapor, right? So this is the phase diagram. That you see, take any, if the pressure is low, lower than 1 atmosphere, then we come here and hit here. So boiling will happen at this temperature, maybe 80 degrees. But if the temperature is higher, boiling will happen here, maybe at 110, 120 degrees, right? So this is the phase line between liquid and vapor. Similarly, there is a phase line between solid and liquid. This line, solid and liquid. So you see, at 1 atmosphere, if I hit it, I hit this line, 0. So if the pressure is normal pressure, then water freezes or melts at this temperature, right? If you are at lower temperature and increase it, then after 0, solid water, which was ice, will change into liquid water. But if you were at a higher temperature and I decrease the temperature, then when you hit 0, then liquid water will become the solid ice. So you see, this whole diagram is the phase diagram. Pressure on one side, temperature on the other side. This line is the line between solid and liquid phases. This line is the phase line between liquid and vapor. So this whole diagram is the phase diagram of water. Now, there is one very interesting point. See this point, which is called a triple point. Why do we call it a triple point? See, if we have any point here, then what two phases are coexisting? On the left you have liquid, on the right you have vapor. But if you are on this point, this is a unique point. It also, just touches solid, just touches liquid, and just touches vapor, right? So this is a triple point. And if you change the temperature or the pressure slightly, you can't have it, right? So this is phase diagram of pure water. Let us now take the example of a metal, pure iron, right? You will see on the next page, we will see the figure. So now it is a metal rather than water and so on. You will see that there are three separate and distinct solid phases. You see, when you heat and melt it, it will be all liquid. When you start to cool it, it does not cool into one solid. It cools into three solid phases: alpha iron, gamma iron, and delta iron. And you already know crystal structure, right? So alpha iron and delta iron have a BCC crystal structure. Gamma iron has an FCC crystal structure. And we just told you about triple points where all the three phases coexist together. So there are three phases coexisting at triple points, and there are three of them: liquid, vapor, and delta iron, solid delta iron. Vapor, delta solid iron, and gamma solid iron. Vapor, gamma solid iron, and alpha solid iron. So you will see on the next page, we will just show you the figure. And this is a remarkable thing. There is no other metal in the world which has three solid phases. This is unbelievable. But again, you know, and we have been telling you that for thousands of years, iron has been the most important manufacturing metal. And even in today's world, iron and steel is the single largest engineering material. And it is because of this particular thing that iron has three solid phases. So if you can play around while cooling iron, that it does not go to this phase, it goes to the other one. It does not go to this phase, it goes to the third one. So it is the same material. By controlling how you cool it after melting it, you can control the properties and so on. So we will discuss it later on, but right now we had covered water just now. Now we want to cover iron and see what are the phases. So let us go to the next page.